Hello everyone. Hope you are doing well. We are Team Loud and Cloud from IT Raurkela. The problem we are working on is improving the targeted vaccine delivery as soon as the massive vaccination program starts in our country, India. So it will be bad to expect that all vaccines for the entire country will be available in initial stages. So there is a necessity of making strategic decisions and wise analysis on what are the conditions of COVID-19 in India at current times, so that vaccine can be delivered to at correct locations with locations of higher risk and priority and to the correct people.
Hi everyone. My name is Harsh. I'll be explaining the risk assessment component which we have built. So as you can see, the risk assessment component here, it is a risk-based heat map of the entire country based on the different constituencies. And what this component does is that it actually tells us the value of the risk that is associated with each district, and the risk value is calculated based on the active cases and the total number of deaths that have occurred in that constituency. So we can see that the key here provided tells us that districts with the lowest risk are green in color, and it moves on to red, which shows the districts with red color are at the highest risk of having new active cases. When we hover over a constituency, we find that we provided here the population of the constituency. We have provided a new total number of active cases that would be in that constituency after 15 days, and the total number of new active cases that will be added to the current active cases. Also, we have provided the value of the risk. As we mentioned earlier, it was based on the value of the active cases and total number of deaths. So the next component that we have built is filter by parameters.
So the filter by parameters component basically provides us the districts based on some parameters which are filtered. So on clicking on risk score, as you can see in the tab, we have three options with which gives us the default, which is normal risk, and we have high risk cases and low risk cases. On clicking on high risk, we will be able to see that this districts marked in red have higher risk. As risk of getting a risk of having COVID cases in future, and this will tell us that these are in high priority regions in future. Next, we can go for active cases, and we can see, let's see active cases low, so that we can understand that these are not like most priority district of most priority in our case. And when we go for population as high, then we will be able to understand that the high population regions will give us the areas where if the active cases rise, then the outbreak or the spread of the virus will be more. So this kind of statistics helps the organization to determine where to deliver the vaccine and to which particular cluster of districts.
So the general statistics is interface that we have built, which tells the user active, confirmed, and recovered cases for each constituency at current moment, which we have the data we have fetched from uh, official websites. So what we can see here is if we click on active, we can find the active cases currently in that constituency. So we can see that the Falkabad we have active cases 112 at the current time. We can also go to the confirmed cases and see the total number of confirmed cases that have happened in that constituency since the pandemic started. And you can also go to the recovered to find total number of people who have recovered from the disease. And
Hello everyone, I'm Abel from team and I'm here to explain the vaccine requirement section of our project. This module can help us prioritize which areas in the entire nation should be vaccinated first. Risk is a factor which is not a direct measure of the quantity of the vaccines required. We are using population data as well to find the vaccine requirements for the state. So if I take the state example as Bihar and I look at the high vaccine risk region, so give it a few seconds and we see that the count of people required shown over here. This count is shown right now over here, but when we have a vaccine ready, we can set up a multiplier which will show the amount of revenue that is required to actually vaccinate people from Bihar. So this was a direct impact that can utilize the revenue generation needed to actually vaccinate a region which has a given amount of risk, and hence the threat of COVID-19 can subsidize given the amount of funds and vaccine. Thank you.
So hi guys, this is Shande. So I'll be explaining the backend part of our code, which comprises of a model that takes in the district-wise COVID statistics of India, and it kind of estimates the urgency of vaccination in that district. So you can see here's the flow chart of our model, how we made it. The model was initially a basic SR model, which is a kind of a district spread, which models the spread of a particular disease, and we added more compartments to it, and we got an enhanced SR model. Then that model was further improved by considering the vaccination scenario, because SIML is not meant for vaccination cases, but we had to also consider that vaccinated people cannot infect or cannot get the disease of COVID, and that's why we enhanced the SI model further to COVID with the vaccination scenario. And then we got a full-fledged SIR model. So this SIR model takes in the time series data, district-wise time series data of COVID-19 in India, and as well for the population, it takes in the census data of India. And once we initialize model for each of districts, and we get model for each of them, and for each of the model we fit the data of that district. Once we fit the data, we predict the new cases possible in upcoming 15 days for the district. Say that's district X, right? Now we take that value is basically integer. It can be 80, 90 or whatever. Now we normalize that value between 0 to 1, and that is we are denoting as risk of COVID in that district. Okay, that kind of resembles the risk of COVID in that area. Further, we are multiplying that risk with the number of susceptibles. That means those who haven't yet got COVID but are also not vaccinated. Right? They should not be vaccinated. So we are multiplying them, and we're getting a vaccination urgency for district X. Now see, this number of susceptibles is the absolute number of vaccines we need for the district. But if you don't have sufficient number of vaccine available with you, then you have to give some kind of priority for different districts, right? And that's where this particular value, that is the vaccination urgency, comes in this. Now this small picture gives the validation of our model, which fits in the COVID data for a particular district, that is Anantapur in Andhra Pradesh, and the fit is quite good. You see the yellow mark is the fitting part, and the real data is the blue one. So as the fitting is quite good, we can say our estimation is quite good. So thanks for this. The front end presentation will come up soon after this. Thank you.